Good morning, everybody. Today we are discussing the next topic of the electroanalytical chemistry 1. So, in the last class, we have discussed the basic principle of the potentiometry. The potentiometry depend upon the potentiometry we usually used to find out the concentration of the analyte solution, in which the concentration is determined by measuring the potential of the electrode, and the analyte electrode is usually known as indicator electrode, and the potential of the indicator electrode depend upon the concentration of the analyte ion surrounded by that electrode. So that is we discussed in the last class, and there are two different type of the potentiometry. And the first one is the direct potentiometry. That means directly we measuring the potential of a indicator electrode, which we can convert into the concentration of the analyte ion which is present in the solution. So today we are discussing what do you mean by an indicator electrode. So indicator electrode means an electrode which is immersed in the analyte solution for determine the potential of the analyte solution. So the potential of a indicator electrode is generally represented as E int, that depend upon the analyte concentration surrounded by that electrode. And this indicator electrode is a very selective to that particular ion, and the measurement is very rapid, and we can reproduce the data at any time. There are so this is the definition of the indicator electrode: the electrode whose potential depend upon the concentration of the ion to be determined. And we can classify the indicator electrode into two different types, that is electrode of the first kind. That means when an ion to be determined is directly involved in the electrode reaction. That means if we measure the concentration of a zinc ion in an analyte solution, that means if our solution is a zinc sulfate solution, we have to measure the concentration of the zinc ion which is present in the analyte solution. So usually we are creating a cell by using zinc rod dipped in that analyte solution, and the remaining other half cell is a reference electrode. If we combine together, we will get a cell. So from by measuring the potential of that cell, we can easily find out the potential of the analyte solution, and finally we can convert the potential into the concentration of that ion. So this is the first kind electrode. So the second kind electrode is that we cannot measure directly the potential of the analyte solution or analyte concentration, but by converting it into another, we can easily find out the concentration. So the definition is to measure by direct potentiometry concentration of an ion which is not directly concerned in the electrode reaction. For example, if we measure the concentration of the Cl minus ion, how we will measure the concentration of the Cl minus ion? So for that we will make silver chloride electron, which is formed by coating a silver wire with a silver chloride, and this electrode can be used to measure the concentration of the chloride ion in the solution. So we first of all we measure the concentration of the Ag plus ion into the solution. Then if the compound is an AgCl, we can convert the concentration of the Ag plus ion to Cl minus ion, because if we have one Ag plus ion in the solution, definitely there is an Cl minus ion remain in the solution. So thus we can indirectly measuring the concentration of the Cl minus ion is known as second kind of indicator electrode. Now, So this is the example metallic electrode that is responsive to the activity of an anion with which it ion forms a precipitate or a stable complex ion. For example, if we measure the concentration of Cl minus ion, we will take the analyte solution as AgCl and it will split into Ag plus Cl minus, and we can measure the concentration of the Ag plus ion in the solution. From that we can convert the concentration of the Cl minus ion, and thus we measure the concentration of the Cl minus ion. So the next is the indicator electrode. We can use the metallic electrode as an indicator electrode. Metallic, if we use the metallic indicator, we are directly measuring the concentration of that ion. An indicator electrode responds readily and reproducibly to change in activity of the analyte ion, and the and we can divide this indicator electrode in another way, that is metallic and membrane electrode. And so metallic electrodes, indicator electrodes, are usually first kind or second kind, or it may be an inert metallic electrode can be used, or redox system can be used as a metallic indicator electrode. For the second type, that is membrane electrode, we can use glass pH indicator electrode or glass IE for other cation, liquid membrane and crystal membrane for a indicator electrode. The last category is the gas sensing probe for detecting the ion or for finding out the concentration of the ion. Thank you.